needs to understand is the Bren School of Environmental Science and Management is an intercrop. We're not just a monoculture college or we're an interdisciplinary mixture. Thank you. Thank you. We have different perspectives and methods that, when growing together, are more productive, more resilient, and better for the environment than just the sum of our parts.
Today, we will tell a story about how this diversity is a source of productivity.
Now we've used it to discover why farmers intercrop in the United States.
If intercropping is so good, why don't we see it everywhere? Does it actually support farmers' goals? And if so, when and how? These are the overarching questions that we're investigating. Today, we'll talk about the definition of intercropping and its agronomic benefits, and then what we've learned about the benefits and costs experienced by farmers and how we're incorporating these impacts into an economic model of intercropping. Agriculture is essential for humanity, and the ways we practice agriculture today have major environmental costs. Expanding agricultural lands drives greenhouse gas emissions and biodiversity loss. And intensifying agriculture by increasing rates of fertilizer, herbicide, and pesticide application on existing agricultural lands can increase yields, but also drives greenhouse gas emissions, air and water pollution, and soil degradation. Feeding humanity while reducing the environmental costs of agriculture will require innovative practices and policies practiced at large scales. In natural ecosystems, biodiversity drives productivity and stability in plant communities. When we apply this principle in agriculture, we call it intercropping, growing more than one crop within the same field during the same season. Here you see an example in northwestern China. These are strips of corn, the taller ones, alongside strips of wheat. Plants compete most intensely for resources like light, water, and nutrients with other plants of the same species. So species mixtures within a field relieve some of that intense resource competition that monocultures face. As a result, we find across a large and growing body of agricultural experiments that intercrops are more productive and have some reduced environmental costs compared to monocultures. I presented here last year on the results of a meta-analysis on corn, soy, and corn wheat intercropping experiments. We've now expanded on that work and find across more than 100 experiments, on average, intercropping increases productivity by about 25% per area of land cultivated. It does this at fixed fertilizer input rates, which means more of the fertilizer applied to the field is used by the crops, and less then remains in the field to potentially enter the environment as air or water pollution. But here in the US, intercropping is extremely rare. Although you might hear of it sometimes at small scales, maybe if you talk to your veggie farmer at the farmer's market, in the mechanized row crop agriculture that dominates our arable landscapes, it's almost unheard of. I had heard on social media about some farmers who are experimenting with intercropping, but at large scales, the USDA, US Department of Agriculture, doesn't even collect data on the occurrence of intercropping in our country. All row crop production is assumed to be monoculture, and any of us who've driven across the Midwest or the Central Valley or anywhere in our country will agree that's a reasonable assumption.
So I was in the audience, just like you, last year at the PhD symposium when Zoe presented her intercropping research. And as a political scientist interested in the social aspects of environmental problems, I asked her from the audience, if this is so good, why are we not doing it at scale in the US? And so that's kind of where our interdisciplinary collaboration started. So first we set out to understand what intercropping practices are used in the US, since it's so rare. And among that subset of farmers, what motivates them to adopt these practices? And similarly, what are the costs and challenges associated with adopting intercropping?
I was also in the audience last year for Zoe's talk. And I had similar questions as Renee from an economic perspective that I asked Zoe after the talk. As a trained economist, I wanted to understand what costs might explain why so few farmers are intercropping. Is it actually profitable? And if it's not profitable, then why are some farmers doing it? Furthermore, if intercropping is not profitable, is it still environmentally beneficial enough to outweigh the costs in such a way that we should be supporting it through policy?
So there's no previous literature research on intercropping and the costs and benefits in the US, which is why we approached our research questions with a qualitative inductive approach. So we did 19 semi-structured interviews with farmers, and they lasted about an hour each. So really nuanced information. So we can learn a lot from the very few practitioners of intercropping in the US. So we asked them about both what they're doing and why. So the interviews spanned across 7 states. You can see on the left here, this is a farm in Iowa. Also, Zoe was able to go in person and visit 4 farms across Iowa this past summer. Had a wonderful time, as you can see. And now we're in the process of transcribing and coding, thanks to our wonderful research assistant, Andy. I don't know if she's in the crowd, but thank you, Andy. Andy.
Addressing our first research question, what does intercropping look like in practice in the US? We find there's 3 main ways that American farmers are growing different crops together. First, relay intercropping. Farmers plant wheat or rye in the fall and then soybeans into the same field in the spring. So those crops overlap for a period of weeks to a couple of months in time. You see here, wheat is being harvested over the top, and soybeans are that darker green crop in between. In mixed small grain intercropping, farmers grow oil seeds, legumes, or small grains in either a full mixture or alternating rows, like you see here, canola in North Dakota. This is canola alternating with peas. And in corn strip intercropping, farmers grow a few rows of corn, alternated with a few rows of soybeans or forage crops, like you see here at a farm I visited in southern Iowa. Corn, the taller crop, alternated with a multi-species mixture that's used for livestock grazing.
To address our second research question, we cataloged the main motivations that the farmers were overwhelmingly reporting to us. So the main motivations that they reported are on-farm environmental and human health. So specifically, they want to reduce soil erosion and increase soil microbial activity on their farms. A majority of farmers also talk about health benefits as a main motivation, whether that's reducing chemical inputs on their farms or increasing the nutritional value of the harvested crops. Lastly, they're motivated by reducing their input costs in their operations. So that means spending less money on fertilizer, seeds, and herbicides.
Addressing our third research question, we've also heard from farmers about the costs and other challenges of implementing intercropping in practice. A year ago today, I thought that small autonomous farm machinery, like the little robot tractor you see here on a demonstration farm I visited in Iowa last summer, would allow intercropping to be implemented at large scales across the US. And we indeed have heard from farmers that for corn strip intercropping, machinery and labor are some of the biggest challenges. But large-scale machinery can be more readily adapted for relay and mixed grain, small grain intercropping. Those farmers instead report that federally subsidized crop insurance is not available for their intercrops, and that's a major challenge. Additionally, small grain intercropping harvests all of the 2 different crops together. And so the farmers then face the equipment and labor cost of separating them, and then additionally have to find markets for more diverse crops.
We can use an economic framework to understand how those challenges and the benefits of intercropping can collectively impact social welfare. That is, the welfare of farmers themselves, as well as the people who buy their crops and experience the effects of pollution from farming. Our interviews suggest that in order to understand these welfare impacts, we should consider the value of soil health and human health to farmers, as they've indicated. But first, it's important to understand whether or not intercropping is profitable without these additional factors. And we're doing this by using simulated productivity gains applied from experimental data applied across the US, which you can see in this map here, in order to determine where and by how much farmers' profits might be changing in response to adoption of intercropping under best practices. However, estimating profitability of intercropping under best practices requires several strong assumptions about machinery costs and fertilizer choices by farmers. We need a more detailed economic model in order to better understand how these costs impact farmer behavior. And one great thing about this interdisciplinary project is showing how these interviews from farmers who are actually engaging in intercropping on the ground was really fundamental in helping us start to develop a structural economic model of crop production. And this model allows us to account for those factors of machinery-specific costs and the possibility that farmers might reduce their fertilizer inputs when they intercrop. Furthermore, we can use this model to assess whether or not policies such as a nitrogen tax might actually encourage more intercropping adoption by farmers. Or if it turns out that intercropping might not actually improve social welfare unless we correct for market failures, such as the lack of insurance availability for intercropping.
Monocultures in our country today, in the large-scale commodity crop agricultural systems we have, are often seen as entrenched and inevitable. We've also heard in our interviews from farmers who articulate feeling disempowered or frustrated with the system that they feel leaves them behind economically while impoverishing the soils and agroecosystems that they cultivate. And these farmers are actively working to re-engineer their farm machinery, experiment with new methods, and network with each other to build a future in which they can take care of the soil and land that's feeding them and their communities while being economically sustainable for themselves and their families. We've, in the great tradition of the Bren Symposium as a genesis of a place for wonderful collaborations, we would love to hear your questions, comments, concerns, and feedback about this research afterwards.
Quickly, we would just like to thank the farmer participants who shared all of their thoughts and perspectives with us. We've learned so much from them. Also, the network of researchers and agronomists that connected us with them, our superstar research assistant, Andy McNeil, and our advisors and mentors. And of course, this research wouldn't be possible without the generous funding from the H. William Cooney Bren Fellowship. And lastly, thank you to the PhD planning, symposium planning team. You guys have created such a great celebration that is just really celebrates our interdisciplinary work as a community. And we also love working together. We just wanted to add that. So thank you.
Wow, thank you guys so much. That was so cool to learn about. And I think we have time for one question, / we don't really, but I think we should do it anyway because I'm very inspired by how this all came together. So I think we should do a question if there are any from the audience.
Did you have any challenges in bringing together your three perspectives, and could you describe one of them?
Any yield.
So started at the beginning.
Yeah, I would say learning terminology was probably the biggest issue. And it was very fun though to learn about the different ways people describe different concepts.
I would say also just like the inductive approach is not, I'm like, it's more common in the social sciences than the natural sciences. So like having kind of, yeah, like kind of having the agronomist kind of come over into my neck of the woods, but also getting really, really interesting and like really helpful ways of organizing the data and like asking questions that I never would have thought of as, you know, from my background. I don't know about all of the things we should be asking about crops. So it's been a really cool way to combine both like content and methods.